Hello, kindergartners, and welcome to our final week. So we're going to be doing engineering design number 4 today, and that's part 2. So last week, we kind of got a good idea of what this activity is last week, and this week we're going to build on it for our final week. This is week 8. Wow, we've been doing this for 8 weeks together already. And we're going to still be working on clothespin structures. My name is Miss Acevedo, and I will be taking you through this activity, and I'm with USC's Young Scientists Program. So I'm going to go ahead and keep going. Here we go. So our learning target is the same. We will be able to create and test out different designs to make the tallest building out of clothespins and popsicle sticks. So we learned last week what clothespins are and what popsicle sticks are. But this time we have a special challenge, and I'm going to share with you in a moment what that challenge is. Are you ready? 3, 2, 1, go. But before we move on and think about what our challenge is going to be, we need to remember that we are being architects, and an architect is a person who designs and builds structures. Structures are houses, buildings, bridges. So here's houses, bridges, and buildings. So that's what we've been doing. We have been building houses, and we've been building buildings as architects these past almost 3 weeks now. So our next vocabulary word that we're gonna remember is engineer. And an engineer also designs and builds structures, but they use science principles to make sure they work. So they don't just build to build and design to design. They think deeply about it, and they think about the science that goes behind keeping buildings, bridges, and houses nice and tall and strong and usable for people. So we're going to keep going. So last week we learned how to build a clothespin structure. So I taught you, and you saw this video here.
Hello, my kindergartner friends. I'm here to show you all the materials that you're going to need to build your clothespin structure. So for our structures today, you're going to need a few materials. You're going to need clothespins. I have clothespins right here. You can find them at a store. You can find them at Walmart or Target or any different place. But you need clothespins. We use this to pin our clothes, but today we're going to use this to build a building. You're also going to need popsicle sticks, okay? You can also buy these at a store close to you, or you can just eat a lot of ice cream and then try to get your popsicle sticks from there. But I think if you buy them, it is a lot easier. So we have just 2 materials that we need today, popsicle sticks and clothespins. Okay, so now I'm going to teach you a few ways on how to start building. Now, I'm not going to give you the answers to how to build your structure today or your building today, but I will give you some tips to help you get started. It will be a challenging process. It tips over a lot, but it will be fun, and you will find a way to make a really tall building with just these 2 materials. So I'm going to go ahead and just show you how the clothespin works. The clothespin works just by simply pushing it down with your 2 fingers. You see that? It opens and closes. And you can use it to connect popsicle sticks. See, I just open and closed it, and open and close this piece. There you go. And now it stands right here. I'll bring it a little bit lower. Now you see that it stands. Now, if I wanted to make my clothespin a little bit taller, or my tower a little bit taller, I can start clipping the opposite way, and I can start stacking up my building tower, and I can use that to make, there we go, to make my structure.
Okay,
hello, my kindergartner friends. I'm here.
I'm going to go ahead and stop it there, and now I'm going to show you and tell you about your challenge this week. So I just reminded you how to clip, open, and close your clothespins and connect your popsicle sticks, and now you're ready for a new challenging task. This week, you're going to create a building out of clothespins and popsicle sticks so that that's the materials you're going to use, and you're still going to make sure that your building stands up on its own and it doesn't lean on anything, and that it uses these two materials. But I have a new criteria for you this week, a new task, and that is that you need to use the least amount of popsicle sticks and clothespins as you possibly can. So that means you're not allowed to use too many popsicle sticks and clothespins. You want to make it tall but use less materials, and that is challenging. So go ahead and pause this video, build your tower, and this time use as little as you possibly can of clothespins and popsicle sticks and make it stand tall. And when you're ready, press play on this video so we can keep going. Okay, so now that you've built your tower and you put clothespins and popsicle sticks together and you use very little of them, but you still made it nice and tall, now it's time to reflect, think about it, and you're going to find a family member or a friend to present your building to, and you're going to answer this question. And it is the same question as last time, but it's always nice to think about what was difficult about our building. And I want you to answer the question, what was the most challenging part about creating your building with less material? So, what was the hardest part? Go ahead and share with someone, and then you can start your sentence with the most challenging part was. The most challenging part was. And we're going to keep going. So now let's consider this new question. What happens to the building if there are less sticks at the bottom? So if you had less sticks at the bottom of your building, what would happen? Share with someone, and you can start your sentence with when there are less sticks at the bottom. And tell me, what do you think happens when there's less sticks at the bottom of a building? Let's keep going. So let's look at some buildings. We learned last week that these buildings have balanced weight on both sides. So when you cut each building down the middle, you see that it is the same on both sides. It is the same on both sides, and that's what keeps them standing tall. These buildings have height. And we know that just like our bodies, buildings need balanced weight to keep them high. Balance and weight affect the height and how tall a structure is. If the building is not balanced or has the same weight on both sides, it can't stand tall and it will fall over. That's what we learned last week, that in order to make tall structures, we need to keep everything balanced on both sides. But there's actually a new trick or a new thing that we can learn to make our building stand tall with less sticks. So let's keep looking. So there is one more element a building needs to stand tall, and that is support. A building needs support. This is a new word that we're looking at today, and I pointed here because support comes from the bottom of something. Support means a strong and heavy base that helps hold something up. So the base is the bottom. So if something is strong and heavy at the bottom, then it will hold up everything else on top, even if it is lighter. So if a building is heavy at top and light at the bottom, then there is not a lot of support. So let's take a look at that. So it says, think about it. What will happen if a building is heavy on top and light on the bottom? So if it's heavy on top and light on the bottom, what do you think is going to happen to this building? You can start your sentence with the building will. So if you said that the building will fall over, you are correct. When something is heavy on top and light at the bottom, it will fall over because of the weight. the light part cannot carry the heavy part because there's not a strong base at the bottom. So, how can you build a tall building with less materials? Well, if you use more materials at the bottom and less materials on top, your building can stand tall because it has support. That is a strong base. So if this is nice and heavy, if it is nice and heavy here at the bottom, a strong base, then it can be lighter on top and you can use less sticks instead of making it all the same. So you can use more sticks on the bottom and less sticks on top to make it still stand tall and strong. This is a way to use less materials and still make a very tall building. So now it's time to show your learning. Rebuild your building. This time, use your new learning to make your building taller but with less sticks. So you still have that same criteria, those same rules. The building must stand up on its own. It can't lean on anything. The building can only use clothespins and toothpicks, but you can only use the least amount of popsicle sticks and clothespins as you possibly can. So think about this new learning, what I just taught you a moment ago, and build your new building and see if you can make it with less materials. So good luck and try your best and show your new learning. So before we get going on our final week, I want to take us through our last scientist of the week, and that is Aprille Ericsson. She's right here. She is an aerospace engineer, so she studied space. She studied science and aeronautical and astronautical engineering in college, so she studied a lot. She was the first African American woman to receive a Ph.D. in mechanical engineering from Howard University. That is such a big accomplishment, and she is a doctor. So Dr. Aprille Ericsson has worked for NASA for over 30 years, and her work focuses on lunar exploration. Right here is a picture of the moon. That's another word for lunar. So lunar exploration means that she explores the moon. So she's an amazing, amazing scientist, and she is an aerospace engineer. So she builds those machines to explore space. So she is amazing. Thank you all for joining me. It's been such a wonderful, wonderful journey these past 8 weeks getting to teach you about humans and the earth, and also about engineering and how we can build things with just materials from our home. It is so fun. It has been so great working with you all, and I can't wait to see you next time. Goodbye, everyone.